All right, everyone, here is what you need to see for questions 1 through 7 on the rotating sky, the observer section. You can go ahead and pause the video so that you can get the information and read it. And I've set the uh, simulator for the question number 7, this one right here. Okay, everyone, here is the section that you need to see for the two systems, celestial and horizon. This is at 42 degrees latitude. All right, everyone, here is the paths of the star section. Information on the rotation of the sky. And information on the rise set stars and circumpolar and never rise stars. Again, pause the video to see these things. And finally, the simulator at 42 degrees latitude showing stars and how they move. Here's the west, the north, east, and the south. All right, everyone, and here is the bands in the sky section. You can read the text to answer the questions. And here's the location of the sun band. Again, pause the video in between these sections so you can observe them more. And here's the moon and planets band. Okay, everyone, I have the rotating sky explorer for questions 17 through 24. We are for Geneva, the first column. Number 17 asks the altitude of Polaris. And that altitude, is 42.7. Number 17. First column, number 18, is the first star of the Big Dipper at the meridian. The altitude at the meridian for the first star of the Big Dipper, number 18, 70.2. Altitude for number 19, 75.6. Altitude for next star, the star that's 11.9 right ascension and 53.7 declination, at altitude 78.3. Next star, here's the right ascension and declination, altitude 74.9. Altitude at the meridian for the next star, right ascension and declination here, altitude here. And second to last star, altitude, and last star, altitude. All right, switching to Melbourne, Australia, the second column, 17 through 24. This location of the world. Altitude of Polaris, 38 minus 38.8. That means it's below the horizon, minus 38.8. Altitude of the first star, the Dipper, at the meridian, minus 9.8. Here's the right ascension and declination, and the altitude. Second star in the Dipper, right ascension and declination here, altitude here. Next star in the Dipper, right ascension and declination here, altitude, what you're going to write in the blank is the altitude, and that is here, minus 1.7, again below the horizon. Altitude of the next star, minus 5. Altitude of the next star, minus 4. Altitude of the next star, minus 2.9. And altitude of the last star, the Big Dipper on the meridian in Melbourne, Australia, is actually 2.7. It is above the horizon. So is the Big Dipper a useful landmark in Melbourne, Australia? No. Nope, it isn't. In fact, you probably need to have need to be at like 20 degrees south latitude to and above to even be able to see the Big Dipper. In order for it to be a useful landmark to point to north, you probably need to get to like at about a plus, well, I suppose where you can probably see it all the time is between 20 degrees. You can see it sometimes between 20 degrees north and 20 degrees south, and all the time above 20 degrees north latitude. Okay, the next section here asks us to look at the star trails. So I'm going to add star trails and get this animation in motion here. You can see that the star trails for the constellation of Orion rise at an angle of 48 degrees in our latitude. Our latitude is 42 degrees, so 90 minus our latitude is 48 degrees, and that's the angle the stars rise at. They set at the same angle as well, 48 degrees. The first part asks you to look northward and show what the star trails are doing. And so what you're going to do is draw a swirl like this, an arrow that swirls like this, indicating the direction of motion facing north. The next part asks you to show what the constellations look like as you face south. Here we are facing south, and you can see Orion in the background there. You're just going to draw a little curve like this with an arrow pointing this way. That's what they're doing south. They're curving like this. The next one, looking towards the east, excuse me, we see that the constellations are going to move up and to the right. And facing west, the constellations are going to be moving down and to the right. And these are in Geneva. We then turn our attention to Honolulu, Hawaii, which is 21 north and 157 west. And the rest of these we're going to be looking east. So 21 north, 157 west. Let's go there. And this is what the stars look like in that location. And looking east, you can see the stars are going up and to the right at a higher angle than they were in Geneva. In Geneva, they were more like this. In Honolulu, they're more like this, almost straight up and down, but not quite. The next constellation, or excuse me, the next location, 0 degrees north and 176 west. That's Baker Island on the equator. And at this location, excuse me, the stars rise directly in the east and go straight upward. And that's very interesting. Next location, Barrow, Alaska, 71 north, 156 west. Now you can see the stars are certainly at a very low angle, rising above the eastern horizon at a low angle and swinging around like so. So you're going to draw an arrow that looks like this at a very low angle, facing east. And then we're at the North Pole. And we'll see what the stars look like there when facing east. So that would be 90 degrees north. And facing, well, really you're facing south every way you face, but facing east or any direction, you're going to see that the constellations are circling around day and night. So you would put an arrow that just kind of points to the right there, like so. And that's star trails. The last set of questions deals with the angle of the rise and set of stars. Here I have Geneva dialed in at 42 degrees north latitude, and note that the stars are rising and setting at an angle of 48 degrees. This is 90 minus Geneva's latitude of 42 degrees. So the stars rise and set, and this is number 40. The stars rise and set 90 minus latitude. So the stars rise and set angle of Geneva is 48 degrees. Let's go to Honolulu, Hawaii here. 21 degrees north. The stars rise set angle is 69 degrees. Barrow, Alaska, 71 degrees. I'm gonna have to go back and look. Oh shoot, Honolulu 21 degrees, Baker Island 0 degrees, and then Barrow is 71 degrees. So here we go. Let's go to 0 degrees first. Stars rise and set at an angle of 90 degrees here on the equator at 0 degrees latitude. In Barrow, Alaska, 71 degrees. The stars rise and set at an angle of 19 degrees. And at the North Pole, stars rise and set at an angle of 0 degrees. In other words, they don't rise and set. They just are all circumpolar. And again, number 40, how do you determine the rise set angle? It's 90 minus your latitude.